Good morning, everybody, or good afternoon, or good evening, whenever you're watching this. I'm going to walk you through the motion of a car going down a ramp. I call this the accelerated motion lab, where you're going to apply those kinematic equations you've been working on to a physical situation. And you have two goals. So on the video, I'm going to time a car rolling down a ramp, and I'm going to do it a few trials, and then we're going to see how far it rolls, and from that, you're going to determine what the acceleration is. And so I want you to apply the process for how you find any quantity given other information. I don't want you to just guess. I don't want you to just choose an equation and then try to fit it when it doesn't work. I want you to go through the process. So to help us start us out, I want you to write the kinematic equations that are in your reference tables. There are 5 of them, but why not restrict it to the last 3? Because those are the 3 relevant ones potentially for this lab. The second problem you're going to do is, once you figure out the acceleration, you are going to determine where on the ramp you have to release it. So I'm just going to draw a quick little schematic, and you can refer back to this later. So let's say that represents the ramp. At the beginning of the lab, I'm releasing it from here, and it's rolling all the way down to here, and we're timing it. And we're given that distance, and from that distance and that time, you can determine acceleration. Like I said, that's part 1. Then, once you have the acceleration, you're going to figure out how far up the ramp. So you're going to place the car somewhere up the ramp, some distance d, such that when I release it, okay, it rolls down and it accelerates, and I want the speed at the bottom right there to be 150 centimeters per second. And that's what this problem right down here is saying. So you know A, you know this, you know something else, you're going to try to solve for D. And then once you make that prediction, I'm going to, on the video, show a car rolling from various positions to see how fast it's going. You're going to choose the trial which matches your prediction of D and see how close to 150 it really is. So, in terms of the write-up, and you probably do this later, I want you to discuss how you solved each problem. So what was measured, I did the measuring, but be clear what was measured and how it was measured, what instruments were used, from when to when, etc. And then don't forget, tell me what equations you're going to use to solve problem 1 up here, and then eventually problem 2. I don't want you putting information in there. I just want you to say, we're going to solve acceleration using this equation, knowing this, this, and this. And then for problem 2, we're going to solve for position with this equation, knowing this, this, and this. All right, so fill that in that place there. You can usually do that after the fact. So in the video, I mentioned something about uncertainty and propagation of error. Ignore that. I do that for my AP because that's part of that curriculum. You're just going to record the distance it rolls, the times in the counts here, find an average time, and then you're going to do problems 1 and 2 here. I've put off to the side a little organization table for you, where I've listed the 5 variables that come up in a situation. You figure out what's asked for. So if acceleration's asked for there, maybe put a question mark. You're making clear what you want. You then put in the values for 3 of these 4. You should know 3 of those 4. And then once you have those 3, you can find an equation from the front page where you wrote them down that has acceleration in it and those other 3 pieces of information. Round appropriately when you get an answer, and put the units that go with acceleration. Then for the problem 2, it's the same idea. You can't use the information here to do this, because the information here, especially the distance and the time, was just to figure out acceleration, not this new problem. What you do know in problem 2 is you know the acceleration, because you just figured it out in problem 1. So you're going to import it there, and you're going to solve for D, and then I'll let you determine what other information you know. You need 2 other pieces of information to help you find the position. And then perhaps what I am anticipating is maybe the most confusing part, but I'm confident you can work through it, is the verification. So like I said, on the video, I videoed 4 or 5 different locations, maybe more, anticipating what your answer might be. And I showed what the speed was. So you're going to put whatever position you predicted here. You're going to find the trial on the video that corresponds most closely to that, and then you're going to write down what my photogate speed is. Now, let's say you predict, we know if I'm releasing the car from a distance of 200 centimeters, you know that your answer for number 2 has to be less than 200 centimeters. So let's say you predict a distance of let's say 100 114 centimeters. And I didn't test 114 centimeters. I might have tested 110 and then 120. So when I give the speed for 110 and 120, you might look at both of those and take the average of the two, and that might best closely match yours. So you might have to make some adjustment from my speed to compare it to what your speed is. And then to finish up, just two things. Do a % difference, and then discuss your level of satisfaction with the outcome of the lab. If you think you made a mistake, then you should go back and figure out that mistake, okay? You know, it could have been a simple calculation mistake, or maybe you chose the wrong equation. And I'll just go into some details why you feel this way. I'm hoping you're feeling confident that you understand at this point how to use those measurements to predict how something's going to behave.